Good day, viewers. My name is Sherry Poshoreko. Welcome to our program 5 for our computer study series for the grade 9. Our lesson today is on flow charts. Right. Now, before we get into details, let's look through the objectives. We are going to look at the definition of flow charts. So that is, what is flow charts? Number 2, describe symbols used in flow charts. And finally, we are going to write an algorithm using a flow chart. Right. Now, viewers, it's very important to know what a flow chart is. A flow chart is a step-by-step graphical representation of an algorithm. It uses different symbols to represent a step-by-step solution to a problem. And each symbol performs a specific task or function. Right. Now, viewers, as you can see here in table 1, it shows different symbols of a flow chart and their functions. Right. Let's get into the details. Begin or start and end or stop. They are represented by the same shape or symbol. This is the symbol that indicates the start or end of the flowchart. Right. Number 2, the input or output. This symbol can be used for both input and output. Input to indicate data entered into the flowchart. Now, output is to indicate the results of the processing out of the flowchart. Great. Number 3, that's now the process or the assignment box. All right. It's represent the data processing, as you can see here. Number 4, decision symbol represent the split in the direction of the algorithm depending on the condition presented, which can be either true or false. Good. Number 5, the flow direction indicates the direction flow of the algorithm. Great. Connectors links different flowchart symbols or link different flowchart shapes. Now, viewers, let's write an algorithm using a flowchart. First, we'll start with the problem. Good. Write an algorithm using a flowchart that will input 2 numbers, right? And output the largest number. Find the largest number between the 2. Good. Now, we need to identify our input, process, and our output. Now, input here will be the 2 numbers. Process is to determine which number is the largest between the 2 ended numbers. Finally, our output will be the larger number. Now, it is important to note that we are not given the exact values of those 2 numbers. Hence, we are going to use variables. Suggested variables are, say, number 1 or n1 or number 2 or n2. Good. Now, let's look at the solution. Now, first we draw the start symbol, then a flow of direction downwards. Then, let's start with step number 1. We draw the input symbol and input 2 numbers, that is n1 and 2. Good. Then we draw the flow of direction pointing downwards. Step number 2. It's a decision where the first number is compared to the second number. Good. Now, a decision box is drawn with a statement: is n1 larger than n2 inside? The arrows pointing out on the right with no underneath points to step number 3, which is the process box. Good. Now, step number 3 is the process box, right? If the answer in step number 2, say, is n greater than n2, is no, then the process box, we write large number n2. The second flow of direction with a yes option points to step number 4. Step number 4, this is another process box whereby n1 becomes large if the number entered in step number 2 is larger than the second number. Good. The flow of direction points downwards to step number 5. Step number 5, output the largest number. And finally, draw the n symbol. Now viewers, can we test our flowchart to check if it's correct? Let's do it. Test data. All right, we've got n1, which is equal to 5. n2, which is equal to 8. Expected results should be 8. Step 1, enter 5 in n1 and 8 in n2. Step number 2, is n1 greater than n2? Okay, or you can say, is 5 greater than 8? The answer is no. So we will go to step number 3. Now, step number 3, n2 equal the largest. All right, so n2 becomes the largest, all right, because 8 becomes the largest. Now, we are going to skip step number 4 because of the condition of getting the largest is satisfied. We now go to step number 5 and output the largest, which is 8, and if, and lastly, and the whole process. Viewers, we are now going to test another set of data. Test data, n1 equals to 10, and then n2 equals to 6. Expected results, n1 is the largest, which is 10. Step number 1, enter 10 in n1 and 6 in n2. Good. Step number 2, compare if n1 is greater than n2. Right? Is 10 greater than 6? The answer is yes. We skip step number 3 and we go to step number 4. Step number 4 is n1 equal to the largest, which means that n1, which is 10, becomes the largest. The condition is satisfied, so we move to step number 5. Good. Now, step number 5, we output the largest, which is 10. Then we end if, and lastly, end the whole process. Viewers, our solution is correct here. As you can see, the expected results are the same as the ones we got when we dry run the algorithm. Now we are going to complete our trace table, viewers, using the flow chart provided to us. All right, let's go through this example. Say we use the trace table to dry run the following flow chart. All right, show the output at each stage. So that's what we're going to do here. Our trace table will have 6 columns. Box, which represent steps. Output is the last column at the end, and in between we have 3 columns representing our variables, which is num1, num2, num3, and lastly a decision column. Right, now we are going to repeat step number 3 to step number 6 several times until a certain condition is met, and then we will stop. The condition is num1 is lesser or equal to 4. While the answer to this is true, we will continue going through the steps. When it becomes false, we stop. Right, viewers, can we now go through the trace table. Let's go through the steps. All right. Step number 1, we will ignore this because it shows the beginning of the flowchart, right? Now let's go to step number 2. We enter 0 in num1, 1 in num2, and 0 in num3. Good. Step number 3 is a question with the decision to be made. Is num1 lesser or equal to 4? Right. Now, the value in num1 is 0, and therefore true. So we write true in the decision box and move to step number 4. Step number 4, num3 becomes the results of adding whatever value that is in num1 with the value that is in num2. And this gives us 1. Right. Step number 5, we have to output whatever value that is in n3. And it is a 1. Right. Step number 6, we write the value in num2 to num3, the value in num1 to num2, and to num1 we add a 1. Right. This will give us 1 in num1 and 0 in num2 and 1 in num3. Now, viewers, let's go back to step number 3 and test our condition. All right. Step number 3, is num1 lesser or equal to 4? The answer is true. In the decision box, we write true and move to step number 4. At step number 4, we write 1, which is a result of adding 0 and 1. Right. Now, step number 5, we output a 1. Good. Step number 6, we write 0 in num3 and 1 in 2, and finally we write 2 in num1. Now viewers, let's go to step number 3. Step number 3, the answer is true. All right. Step number 4, the answer is 3. Okay. Step number 5, the output is 3. Good. Step number 6, 1 in num3, 2 in num2, and 3 in num1. Now, we go back to step number 3 again. All right. Step number 3, the answer is true. Okay. Step number 4, the answer is 5. Step number 5, the output is 5. Now, step number 6, 2 in num3, and then 3 in num2, and then 4 in num1. Right, let's go back to step number 3 again. Step number 3, the answer is true. All right, step number 4, the answer is 7. Step number 5, the output is 7. Step number 6, 3 in num3, and then 4 in num2, then 5 in num1. We go back to step number 3 again. Step number 3, this time the value in num1 is 5, and that makes the answer false. Now, because the answer is false, we will move to step number 7, and that ends our flowchart. Good. Viewers, as you can see, our trace table is correct as per our steps or boxes of the flowchart. Now, let's quickly have a look at what we have learned this far. Viewers, before I conclude our lesson for today, let me just give you an activity to do. A town contains 5,000 houses. Each house owner must pay tax based on the value of the house. Now, houses over $200,000 pay 2% of their value in tax, right? While houses over 100,000 Namibian dollars or dollars pay 1.5%, right, of their value in tax. And finally, houses over $50,000 pay 1% of their value in tax. Now, all others pay no tax. What you have to do is to write an algorithm to solve this problem in a form of a flow chart. That brings me to the end of our lesson for today. That's program number 5. I hope this lesson was informative. Thank you so much for viewing. Until next time, bye-bye.